Hello and welcome to this learning video. In this learning video, we are going to talk about the applications. In the very beginning of this unit, we have talked about numerous applications of differential equations. Here in this learning dialogue, we'll be actually solving the applications or actually solving the problems that you may encounter in near future or maybe in this year. Okay, so particularly in this learning video, we are going to talk about the application of differential equation to simple electrical circuit. That electrical circuit may be an LR circuit or LCR, it depends on the given problem. Okay, so to understand the problem which we are going to solve with the help of differential equation, you must be familiar with the basic terminologies. So let us see what these terminologies are. So these terminologies, or first of all the notations are, for current we are going to denote it by I, sometimes capital I, sometimes small I. It depends on whether it is given as capital I or small I in the given problem. Then charge will be denoted by Q, then resistance by R, inductance by L, capacitance by C, and electromotive force or voltage by capital E. Okay, then we may be sometimes we will be given a differential equation, sometimes we have to form the differential equation and then we have to solve. So in such cases these things will be very handy. The things like voltage drop across inductance is L di by dt. Second thing, voltage drop across resistance is Ri, and the third thing is voltage drop across capacitance is Q by C. Okay, so these three things will be handy in the formation of the differential equation for the given electrical circuit, and these will be the notations that we are going to deal with throughout the problem on simple electrical circuit. Okay, so it's time for you to let you know these steps in the working rule. Okay, so let us see the working rule and then we'll solve the problems on this in the very next learning video. Working rule. Working rule. So the very first step in the working rule says you have to write down the given equation. So the very first thing is whatever equation is given to you, you have to write down, and sometimes if the equation is not given to you, then you have to form the equation. Okay, but in most of the times equation will be given to you. So first of all, write down the given equation. Write down the given equation. The second thing that you can do is convert the given equation into a higher order differential equations. Okay, so the second step is convert the given equation into higher order differential equation. Okay, this is the second step of the working rule. Once you have converted the given equation into a higher order differential equation with constant coefficient, let me write it precisely. Higher order differential equation with constant coefficients. Then the third step says once you get the higher order differential equation with constant coefficient, then the next thing, you are smart enough to find out the complementary function. So the third step is write complementary function. write complementary function. And what's that complementary function? That complementary function we denote it by CF. Okay. After finding out the complementary function, you just find the particular integral. Find the particular integral, and that particular integral we denote it by pi, and let me write it precisely, if applicable. So if we have something on the right hand side, then only we have to find out particular integral, otherwise pi would be 0. Okay. The very fifth step is, after writing down the complementary function and particular integral, write down, it should be write the complete solution. Write the complete solution. And the sixth step says, make use of what? Make use of given condition. Make use of given conditions to find out the values of arbitrary constants and put these values in the complete solution. Okay, so this is the working rule of the application of differential equations to the simple electrical circuit. Okay, so I hope this is clear to you. So the very first thing that you have to do is write down the given equation. The second thing is convert the given equation into higher order differential equation with constant coefficient. Once you get the higher order differential equation with constant coefficient, then you have to find out the complementary function. And you know how to find out complementary function. Write down the auxiliary equation for the higher order differential equations with constant coefficient. Find out the roots. Then according to the different rules that depends on the nature of the roots, we write down complementary function. After finding out complementary function, you have to find out pi, and pi is also, we have different rules, 5-6 rules for finding out pi. So apply the appropriate rule to get the proper pi, and once you get it, write down the general solution CF plus pi. Sometimes it's called general solution or complete solution. Okay, and at last some values or some condition would be given to you. Will make use of those condition in order to get the values of arbitrary constant, and then whatever values of arbitrary constant you are getting, you have to substitute it in the complete solution, that is in step 5. Okay, so I hope this is clear to you. So in the very next learning video, we are going to start with the problems on simple electrical circuit. So thank you for watching this learning video and have a good day. Thank you.